Okay, so I'm on question 2 of the trigonometry missing sides iMaths exercise. So it's the harder questions. Okay, so we've got question 1 here. It says, work out the missing side x, give your answer to 1 decimal place or better. Then the first one, ABC is an isosceles triangle. ABC is an isosceles triangle with AB equal to AC. So that's 14, that's also 14. So isosceles triangles, just to remind you, are the ones with 2 equal sides, 14 and 14, and then 2 equal angles. So if that's 67, then this is 67 along the bottom as well. And then there was a dotted line drawn down the middle, which is like a line of symmetry, a mirror line. And then the 2 little markers there telling you that those 2 sides are the same. So we've got to work out this length x. So what we need to do is kind of completely ignore for a minute the half of the triangle and just think about the fact that when you split it down the middle there, it's split it into 2 right angled triangles. So I'm going to think about that right angled triangle on its own. So in that right angled triangle, say on the left, but could just as well be on the right, we've got the 67-degree angle. And then the 14 in that right angled triangle is the hypotenuse. So 14 hypotenuse. And then, well, we're trying to figure out the x, but we're going to do it by figuring out what half of the x is. So that half of x there is the adjacent side in relation to the 67. So we're going to use adjacent and hypotenuse. That's cos, isn't it? So struggle to remember that for a second. Cos, so cos equals adjacent over hypotenuse. I'm going to go over here with this. Cos of 67 in this case is adjacent over hypotenuse. So let's just call it adjacent. So equals adjacent over, and then the hypotenuse is 14. So cos 67 equals adjacent over 14, and I'm going to multiply both sides by 14 to get the adjacent side on its own. So 14 cos 67 is the adjacent. So the adjacent equals, just going to fence off my diagram there. Kind of wish I had a bit more space because that's kind of messy, but never mind. So get my calculator, get it into scientific mode, clear all the stuff from last time. So I've got to do it kind of backwards on here. 67 cos times 14 is 5.47, and then the x is going to be 2 times that. So x equals 2 times the adjacent, because it's 2 of these. So 2 times 5.47, which is, just multiply that by 2. So 10.94, I'm going to call that 10.9 to 1 decimal place. So onto the iMaths, 10.9 to 1 decimal place, and then onto the next question, which is a rectangle with lots of, well, it's got diagonal lines in it, which is making lots of isosceles triangles. So we'll just draw that one out. Okay, well, there's lots of ways to approach this, but basically we've got, well, it says ABCD is a rectangle, okay, and diagonal lines. So if I split, first of all, we've got lots of equal sides there in that rectangle, making, that's an isosceles triangle, that's the same isosceles triangle on the other side, and then these two are the same isosceles triangle as each other. So if we split those down the middle, if we split any isosceles triangle down the middle, it'll make a right angled triangle. I'm just going to draw out this triangle again up here. Boom, 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 very roughly. So that's this triangle here, but drawn up there, and that's going to be half of the 18 along the bottom, and we know that it's 62 degrees in the middle here because it's the same as this 62 at the top. So taking half of it, that's going to be 31 degrees at the top. And then finally we'd quite like to figure out this edge here, because that edge there is half of the x. So in relation to the 31, the 9 is the opposite, and the side that we'd like to find out is the adjacent, because you've got a right angle in there, and that's the hypotenuse. So in this triangle here that I've done in red over here, we've got adjacent and opposite in the problem, and that's tan. So tan equals opposite over adjacent. In this case, tan 31 equals 9 over the adjacent. Tan equals opposite over adjacent, and we're trying to figure out the adjacent. Now, because the thing we're trying to figure out is in the bottom, the denominator of the fraction, that's going to take us an extra step to get rid of it. So I want to get rid of this fraction here, 9 over adjacent. So I'm going to multiply it by the denominator to get rid of it. So multiply by the adjacent to get 9. But then I've got to multiply by the adjacent on the other side. So I get the adjacent times tan 31 is equal to 9. And I'd like that adjacent side on its own. So I'm going to have to divide by the tan 31 to get it on its own. So adjacent equals 9 over tan 31, and that's something we can do on the calculator. So clear all that from the last question. 9 divided by brackets 31 tan, stupid calculator where I've got to do everything backwards, 14.97. so the adjacent is 14.9785 and some more. And that adjacent side is half of x. So x is equal to 2 times the adjacent, which is 2 times 14.97. So that times 2, 29.95. 29.95. So if I want to round that to the nearest one decimal place, I'm cutting it off there, 29.9, and then I'm saying because that's a 5, it's going to make that round to 30.0, and I'm leaving the 0 in just to express the fact that it has been rounded to one decimal and not just the nearest whole number. So 30.0 is what I'm going to fill in on iMaths. 30.0, in it goes. And let's have a look at the next question. So here we are on my pad for the last question, and this question says ABC is a right angled triangle. AD, this line here, AD, is a bisector of angle BAC. So angle BAC is the angle that starts at B, goes through A and up to C, that angle there. And it's saying that line AD is a bisector. It cuts angle BAC in half. So where they've marked that as 19, that's telling us that we've got 19 down the bottom as well. It's a bisector of the angle. It cuts the angle in half. Now somebody mailed me with this one and asked, well, they were convinced they'd got a different right answer, and they'd made the mistake of thinking that because that's x there, then it also has to be x there. But if you think about it, if that's 19 and that's x, and then another 19 makes it another x, what if it was 190? Would you expect it to be 10 times as high? But if it was 10 times as high and 190 degrees, the angle would be coming back round the other side, because 190 is more than a straight line. So you can't just say that because the angle doubles, the length there doubles. So what you have to do with this one is think about two different right angled triangles. You've got a little right angled triangle there with an angle of 19, and then you've got a bigger right angled triangle with an angle of 38, and you can work out the sides here, BD and BC, which are both opposite their angles, using tan. So that was a bit of a mouthful, but let's show you what I mean. So BD is opposite the 19, and the adjacent side is 27 in this smaller triangle. So I'm going to write, let's go up here, so remembering that tan equals opposite over adjacent, that's not very well written, but never mind. So tan equals opposite over adjacent. So in this smaller triangle, tan of 19 equals opposite over adjacent, BD over 27. BD over 27. So BD itself is 27 times tan 19. So that bit there is 27 tan 19. Now let's go a different colour for this, see if my red will hold out. So meanwhile, thinking about the big triangle ABC, we've got an angle of 38 in the whole thing. And if I want to work out the big angle BC, then BC is opposite the 38 and the adjacent is still 27. So tan 38 equals BC over 27, and multiply both sides by 27. 27 tan 38 is equal to BC. So this whole big side of the triangle is 27 tan 38. I don't know how clear that is. I need some better pens again, I think. These don't last very long. So anyway, the side X is just the 27 tan 38 minus the 27 tan 19. So X equals 27 tan 38 minus 27 tan 19. Little not strictly necessary algebra step. I can factor a 27 out of that and say that's the same as 27 times tan 38 minus tan 19. That might just make it a bit easier on the calculation. So that whole thing comes to around 11.8 to the nearest decimal. So let's get on to the iMaths and just put that in. So 11.8, let's mark it. And that's satisfying, isn't it?